Today, we're going to unpack the story of IonQ. This is a company that's not just building quantum computers, they might just be building the future of computing itself. We're going to look at their unique tech, the kind of impossible problems they're starting to solve, and, why Wall Street is betting so big on them. So let's just start with the biggest question of all, right? For years, the whole quantum race felt like it was just about who had the most qubits, the basic building blocks. But that's kind of like judging a sports car just by the size of its engine. The real question is, how does it actually perform on the track? How useful is it for solving real problems? Well, IonQ's answer to that is a metric they came up with called algorithmic qubits, or hashtag AQ for short. You can think of it as a real-world performance score. It's not just counting qubits, it's measuring how well they all work together to run a really complex program. So an hashtag AQ of 36, that doesn't just mean 36 qubits. It means 36 high-quality, fully connected qubits that are ready to do some seriously meaningful work. It's a benchmark that actually measures what matters. And the system that pulls off that impressive hashtag AQ score, it's this, the IonQ Forte. So let's pop the hood and see what makes their top-of-the-line machine tick. The Forte is really the crown jewel of their lineup right now. And the key phrase to pay attention to here is software configurable. This isn't just some static piece of hardware. It's a dynamic, flexible system that you can actually tune to the specific problem you're trying to solve. All right, let's run through the specs, and we'll do this kind of quick fire. First up, the raw count. The Forte system is working with 36 physical qubits, but like we just said, that number is only one piece of the puzzle. The quality of those qubits is what really makes it special. Just look at this number. That is an incredibly low error rate for a single operation on one qubit. We're talking 2 mistakes in 10,000 operations. In the quantum world, where everything is unbelievably fragile, getting that level of precision is absolutely critical. It's just exceptional. Now, for 2-qubit operations, this is where the real magic happens. This is where you get entanglement, where you link 2 qubits together so their fates are intertwined. It's way more complex, but even here, Forte keeps an error rate of less than 0.5%. That is so vital for running the powerful algorithms of the future. And finally, you've got your spam error. And no, not the email kind. This stands for state preparation and measurement. Basically, it's the chance of an error when you're setting the qubits up at the beginning and reading out the result at the end. And again, at just 0.5%, it just proves the incredible end-to-end quality of this whole system. So the big question is, how in the world do they pull off these numbers? Well, it all comes down to the fundamental technology they chose to bet on. Let's dive into the core innovation that makes this all possible: trapped ions. Using individual atoms, these trapped ions, as your qubits gives you some massive advantages. We've already seen proof of that first point, the highest gate fidelity. But it also gives you all-to-all connectivity, which means any qubit can talk directly to any other qubit. That is a huge deal for writing efficient code. Plus, trapped ions have incredibly long coherence times. That's how long they can hold their quantum state, because they're basically floating in a vacuum, perfectly isolated from all the noise of the outside world. It's just a really powerful and kind of elegant foundation to build on. And let's just pause on this term for a second: gate fidelity. Think of it like this. It's the reliability of your computer's most basic moves. Every single time you perform an operation, there's a tiny, tiny chance of an error. High fidelity means that chance is vanishingly small. That lets you run much longer, much more complex calculations before the errors start to pile up and just destroy your result. It's truly the bedrock of useful quantum computing. Okay, so the tech is amazing. The specs are incredible. But what do you actually do with it? This is where things get really cool, where the technology meets the real world to take on problems that are just impossible for even the biggest supercomputers we have today. And look, this isn't just some theory on a whiteboard. IonQ is already in the trenches working with major industry partners to pull quantum computing out of the research lab and put it to work on high-value practical problems. I mean, this partnership with Airbus is a perfect example. They took on cargo loading. Think about it. How do you fit a super complex mix of different shapes and sizes of cargo into an airplane in the most efficient way possible? For a classical computer, the number of possible combinations just explodes into a number that's practically infinite. But for a quantum computer, this is exactly the kind of mind-bending optimization problem it was born to solve.
And cargo is really just the tip of the iceberg. The same exact principles are being applied to other insanely complex fields. Imagine simulating a new molecule for a life-saving drug, something that's just way too complex for our computers today. Or think about finance, modeling the risk of a portfolio with thousands of interconnected assets. These are billion, even trillion-dollar challenges.
Now, when you start talking about solving trillion-dollar problems, you can bet that Wall Street starts to pay very close attention. So let's shift gears from the tech itself to how the financial world is sizing up IonQ's potential. If you look at the consensus from 12 market analysts who cover IonQ, the feeling is overwhelmingly positive. I mean, 8 out of 12 rate the stock as either a buy or a strong buy. That's a huge vote of confidence from the experts who think IonQ is positioned to do really, really well. And you can see why they're so bullish right here. The forecasted revenue growth is just explosive. We're not talking about slow and steady gains here. We're talking about revenue more than doubling this year and then nearly doubling again next year. That's the kind of exponential curve that gets investors very, very excited. All that optimism gets boiled down into the average analyst's price target, which right now is sitting at $65. It's Wall Street putting a number on their big bet on IonQ's quantum future. So when you put it all together, from the fundamental physics of trapped ions to powerful hardware like the Forte to real-world applications and massive confidence from the market, IonQ has built an incredibly compelling story. Let's just wrap this all up. And that really is the ultimate question, isn't it? What we've looked at today is just a snapshot of what IonQ can do right now, a machine that's already tackling huge logistical challenges. But this technology is moving forward at a breathtaking speed. So if this is what's possible today, what currently unsolvable problems in medicine or climate science or AI are going to become trivial tomorrow? That's the future IonQ is trying to build, and it's going to be fascinating to watch.